Okay guys, this is our lesson 6.4 part 1 factoring review. Today is just going to be a review of all of the things that you should have learned in Algebra 1. Tomorrow we're going to add a few more things about factoring so that we can do some more complex problems now in Algebra 2. So just take a second to remember factoring is the opposite of multiplying. So when we multiplied, they would give us a problem that had parentheses and they wanted us to distribute and simplify what that was. When we factor, so that's what we did on the last test, and when we factor, they're going to give us a polynomial written out and ask us to move it into parentheses. So, for example, we have 3 different types that we're really going to talk about today: shortcut, grouping, and difference of squares. Shortcut, if you had me last year, you may remember what this means. If not, it's just, this is what I'm going to call it. It's anytime we have a equals 1. So that would be if we had something like x squared plus, let's say, 3x plus 2. This would be a polynomial that would work for a shortcut method. And to factor that, I'm going to talk more about how to do that, but the factoring is going to give us an answer that looks like x plus 2, x plus 1. So that right there would be your factored answer. Grouping is when they give us 4 different things. So grouping, you are given 4 terms, and we're just going to group them and pull some things out. Again, I'll touch on that here in a little bit. And then difference of squares, I'm going to touch on that later too, but you may remember that difference of squares is when you have 2 perfect square terms, so x squared and 25, for example, and the middle part is a negative sign. Again, I'll touch more on exactly how to factor that here in a minute. So let's take a second to look at our shortcut method. So here's shortcut. Remember, it's called shortcut because we have a equals 1. So what we want to do is take a second to think about what are each of these going to factor and how do we even factor that. So this very first example here, I'll just call this example A. Our goal is to pick 2 numbers. So 10 is what they're going to multiply to give me, and negative 7 is what they're going to add to give me. So I want 2 numbers, we can write it like this, that multiply to give me 10 and add to give me negative 7. And if we think about that, it may take you a minute to think about those numbers, but negative 2 and negative 5 satisfy that requirement. So shortcut says that I can jump straight from those 2 numbers to my answer, which is going to be x minus 2, x minus 5. Okay, we're doing the same kind of thing here on B. I want 2 numbers that multiply to give me 4 and add to give me 5. If I think about those 2 numbers, they are 4 and 1. So my answer then is going to be x plus 4, x plus 1. Last one. See if you can pause and think about the numbers yourself. I want 2 numbers that multiply to give me negative 24. They're going to add to give me 5. And check your signs if you have to, but my 2 numbers should be positive 8 and negative 3. Positive times negative is the only way I can get this negative answer that I need to right here. And then 8 plus negative 3 gives me positive 5, so my 2 answers, or my 2 factors rather, are going to be x plus 8 and x minus 3. So this is just a quick reminder of what our shortcut method is today. This is something that it may take you a minute to come up with the numbers, but the process itself should be relatively easy once it comes back to you. All right, I'm going to warn you, this slide is going to be long, this section, because I'm going to work the same problem 3 different times. I just want to show you 3 methods. You are welcome to choose whichever one you want to work these out, so you just pick whatever works best for you. All of these are for when a does not equal 1. So just notice that's because the front number is not a 1, it's a 2 or just anything else. So I cannot do shortcut with this method. So the first method that we learned last year, one of the most common ones, is called AC. A and C, that's my first and my last numbers. So to do AC method, we multiply those together. so negative 24. And this is where we listed out multiple pairs, and we were trying to get our goal number here is negative 5. So if I think about things that multiply to give me negative 24 and are going to add to give me negative 5, that's going to be 3 and negative 8. And what we do is we use that to split this middle term. So if I do that, I'm going to rewrite my problem. I now have 2x squared plus 3x minus 8x minus 12. Now you should notice that there are 4 different terms there. So this is now where we're going to use grouping. So you may want to label that this specific step is now where we're going to do grouping. So I'm going to group these into 2 groups, and now I'm just going to pull out the GCF for each group. So the first time I look at it, I'm just looking at this first portion, 2x squared plus 3x. I know that I can pull an x out of both of those right here. And then in the second set, I can pull out a negative 4. That's my greatest term I can pull out. And now I'm going to divide. Remember, GCF comes to the front of the parentheses. If you divide, that gives you 2x plus 3. Negative 4, that's my GCF at the front of the parentheses. Divide to get the inside, that gives me 2x plus 3. And remember, that's the goal. That's like the magic of this whole process, is that the 2 inside parentheses must match. If you're writing down notes on this one, you should say the 2 inside parentheses must match. Now, because those match, those are now my greatest common factor, so they become the first factor in my set. And then my GCF numbers here at the front come together to form my last factor, which is x minus 4 now. All right, there is your AC method. Okay, box method is you're doing the same thing. It's just a kind of a different way to organize and think about it. So in box method, we're going to draw ourselves our box. Remember, first number goes in the first box, 2x squared. Last number goes in the last box. We have to multiply those. So we're thinking about what gives us negative 24. So exactly the same way we started AC method, my answer is 3 and negative 8. So we fill in these other 2 boxes. We're going to fill those in with 3x and negative 8x. It doesn't matter which one you put in which box. And now, if you can think back and remember from our box method, with this, we're now trying to figure out what can I pull out of each column or row. So if I look at this first column, both of those have a 2x, so I'm going to pull that to the top, 2x. If I look at my second column, so the 3x and the 12, they both have a 3. That's the GCF I can pull out. Now I'm going to look rows, so my top row across, I can pull an x out of both of those. And then my bottom row across, since it starts with a negative, I'm going to pull a negative number out, so I can pull out a negative 4. And notice now these become my 2 factors. So again, I'm going to get 2x plus 3 because that's a positive 3 and x minus 4. You should really use this method only if you've ever done box before or if you're following what I'm saying now. So there's box method. Okay, this last method, bottoms up, is a little strange. It's actually the method that I used in high school. I just kind of figured it out, but it's not really something specific that follows the other patterns. So on these, we want to think about, I like the shortcut method, like we did on the previous slide, because you just come up with 2 numbers and then you have your answer. The problem is this 2, so we're going to trick the problem and move it to the end. So my problem is now going to be x squared minus 5x minus 24. So now I'm going to pretend like this is my current problem, my x squared minus 5x minus 24. So I want to think about what are my 2 numbers that are going to multiply to give me negative 24, add to give me negative 5, and those are 3 and negative 8. So I'm going to pretend like I can go ahead and write my factors, x plus 3, x minus 8. Well, I'm really close to the answer here, but the problem is there's supposed to be a 2, and clearly I don't see, if I multiply, I'm not going to get 2x squared, I'm just going to get x squared. So this is where the bottoms up, quote unquote, comes in. So we're going to put 2 over here. Because we multiplied the end by 2, now we have to go back and divide and figure out where does it divide. Well, 2 does not divide out of 3. So that's where we're going to take the bottom and bring it up. That's where this term comes from, which is going to give me 2x plus 3. On the second factor, 2 actually does divide into -8, which leaves my next factor as x minus 4. Okay, so I've just shown you 3 different methods for the same problem. This screen should look kind of chaotic to you, but I want you to pick one that makes the most sense, and that's what you're going to really probably stick with for most of what we're doing. Your goal is to become quicker, so whatever method you pick is one that you need to be very proficient in. All right, I'm going to show you one more example using the bottoms up method, just so that you've seen it before, because personally that's my favorite and I think it's going to be a lot quicker than some of the other methods. So one thing you might notice weird about this specific problem is that this is x to the third. That's because each one of these terms has an x in it. So my first step is going to be to take my GCF out. So all of those have an x in common, which means my new problem is now going to be 3x squared minus 1x minus 4. That's a typo. That should say minus 4. All right, and then bottoms up tells me I need to get rid of that 3 for a minute. So now my new problem that I'm thinking about is really x squared minus 1x minus 12. So I'm trying to think, what are my two numbers that are going to multiply to give me 12 and add to give me -1? Oh, sorry, multiply to give me -12. And those two numbers are going to be -4 and +3, which are going to give me the factors x minus 4 and x plus 3. And now we just need to go back to our previous steps and see what pieces did we lose. So we lost a 3 here, which means I'm going to have to do bottoms up. Here I'm going to get 3x minus 4. On the second one, 3 actually does divide by 3, so I'm going to get x plus 1. And then the last thing that I need to do is look all the way back at the beginning and remember my GCF. So that has to come in, and it's just going to go at the very front, which means my final answer is this right here. That is so much quicker than either of the other methods, so hopefully that makes sense to you. Okay, and here we are at the very last pattern that we need to talk about, difference of two squares. This is just an example showing you if the first thing is a perfect square and the second number is a perfect square, then we can use this. Remember, you have to have subtraction, and then your answers have a plus and a minus. So the easiest thing for me to do is probably give you an example to write down. So perfect square numbers, first of all, you may want to make a list of those out to the side. They are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Just be able to recognize those. So for example, if you're given 25x squared minus 4, that's going to factor to become 5x. Right, I'm going to split the 25 to make it into 5x. And then I can split my -4 to become +2 minus 2. Another example, 36x squared minus, let's do 49. That would give me 6x plus 7 and 6x minus 7. Because this splits into 6x, 6x. This splits +7 minus 7. Okay, so we'll look at kind of some trickier examples with that tomorrow, but just remember this difference of squares pattern for tomorrow.